Hey everyone, so today I got a student from York University hopping in. Could you quickly just introduce yourself of like what school you go to, maybe what year you in, how many lead code questions you've done, and some of the companies you're targeting, then we can work from there.
Yeah, hello. Yeah, thank you for having me. I'm Ricky. I go to York University for computer science. I'm currently a fourth year student. And I guess like right now I'm just generally aiming for any tech company that I think will like help me become like a better or like generally good software engineer. So I'm not too picky in that regard.
Okay, so for you, you're more prioritizing growth over like name or anything like that for your first
Uh,
job.
It's not my first job, but kind of, yeah. I just want to like go to a place that has like kind of clear standards, like clear code reviews, so and also like pays well because after graduating I don't want to like kind of be unemployed for a while, so
Yeah. Are
that'd be
you
nice.
are you
Yeah.
targeting working in the U.S. or Canada?
I'm fine with either.
And then what internships have you done? Have you done any yet?
I've done a few. I've done like one at a startup and then like a few at the banks,
Nice.
so like they're okay, but yeah, not too much you can really do when like some of them are kind of slow.
Yeah, like the banks, like you're probably like TDs, Banks and stuff.
Yeah.
How's your job hunt looking?
I haven't applied too much. I mean, I did apply to Capital One recently.
Mm-hmm.
I actually did their code signal yesterday.
Wow.
I did like Q one, two, and three just fine, but I had a typo in Q4, so I couldn't finish it.
I
So
see.
sad.
So, when do you graduate again?
I graduate next year.
Okay. When is that? Like August, or are you
Uh,
July 2026 kind of thing?
no, kind of like August 2026.
Okay. So you
Yeah,
should. That's good. You're grinding leak code a whole year before you even have to interview. That's good.
yeah.
So
Kind of on and off though.
things are honestly jobs are gonna start dropping probably in the next few months. Yo, John, what's up? But yeah, a lot of things are gonna be dropping in the last couple months or the next few months. So I would keep looking out for new grad positions even in July and August, honestly, because they're gonna start interviewing people in September and stuff. That's
Hmm.
gonna be their first wave of interviews because they're trying to line people up for May, July, August, right?
Yeah.
So
So,
so right now is the perfect time to lead code for the next 3 months, and then September, October, November you should be doing interviews. If none of those fall through, keep applying, and then hopefully January, February, March you get more interviews and you land those. That's kind of how mine went.
appreciate it. Yeah, thank you. I'll keep that in mind for sure.
Yeah,
I want to be consistent this time. I've done it before, but I'm not really that consistent.
yeah. So
Yeah.
how many lead code questions have you done?
Um, Pretty much like all of the Neat Code like 150, like the
Wow,
first half of it.
lead code only the first half, or so 75 questions?
Yeah, like the kind of like the basic like array, binary search, two pointers, up to like uh, just kind of getting into DP now.
Okay. So let me just walk you. Okay, how are you with arrays?
I think I'm okay. Yeah,
If you had to give yourself a rating out of 10,
I'd say a good like 8.
8. Okay. What about linked list?
Linked list, I'd say like about like a 7 or 8. Yeah,
Okay, you're pretty comfortable with those. What about what about trees?
that's like a 5.
5. What about graphs?
Same thing, like a 5.
What about binary search?
I'd say like a good like 7 or 8 as well.
Okay, pretty comfortable with that. Let me see. What about more complicated? Well, I guess you said you're not that familiar with trees and graphs. So I would make sure you're very comfortable with trees and graphs because those are probably the most asked questions across all the different companies.
Okay, okay.
Yeah, but arrays and linked lists, that's pretty good. Like if you have a handle on those, it's pretty good.
Yeah.
All right. Okay. I'm gonna find you some questions based on what you answered here. All right. I got the first question. So, yeah, pretty much we're gonna simulate a real interview here. This is an interactive code editor. Feel free to run the code as much times as you like. Feel free to choose the programming language that you're most comfortable with. We're gonna prioritize working code walk me through the solution for writing the code. I want to make sure that we're on the same page, and yeah, how's that sound?
Yeah, sounds good.
Okay. So I'm gonna give you the first question here. So yeah, I'll read it out to you real quick. We're pretty much given an array of integers. Wait, let me fix this up. So we're given an array nums of integers where all of the numbers are between 1 and n. We need to return an array of all the integers that are actually missing from that range, right? So you can see this array of nums, 5 and 6 are missing out of here.
Okay.
Example 2, 2 is missing. So yeah, I'll let you go ahead and read that now.
Yeah, seems like relatively straightforward with your explanation too. I guess like one thing that kind of intuitively came to mind is that we kind of track the numbers. Like, sorry, no, we have like another array, for example, where we track if the number has been seen before, or rather if it exists. So, for example, like tracking by using their indexes. So, for example, the first number is like 4, right? So we just have like a bunch of, maybe we'll just have -1s to start with. And so if we see the first number 4 in our new kind of storage here, we kind of mark this up as appeared. So like 1. I guess like for visual, just to show it visually, we just have it as 0 here.
Sure.
And then we kind of check for 3. That's also kind of a 0. I'm kind of doing the order wrong, my bad. Doing 1 based indexing. And we kind of go continue the same way for like 2, so this will turn to 0 as well. And so by the end of kind of this storage solution, we run through the array and we kind of check based on their indexes if the numbers appeared before. So I guess like for 5, for example, it still stays like -1, and the same for 6. So we kind of add that to our resulting array. If that's made any sense.
So this array is gonna track what we've seen.
Yeah.
Okay, so this one, if this is 0, that means we saw number 3.
Yeah.
Okay. Yep.
Yeah.
Okay. And then what? We're just gonna loop through numbers? Like what's
Yeah.
the algo?
So we'll iterate through this and we'll track the numbers we've seen in the storage array. And then afterwards we'll loop through our storage here and kind of append the ones that we haven't seen yet to our resulting array.
Okay. Sounds good. Yeah, makes sense.
Sounds good.
Sounds good to me. Yeah.
And then I guess like I'll do like a second kind of dry run. So for example, like the for example 2, we'd have like an array of like length of 2. Yeah, this one. Actually, yeah, how do I want to kind of store this? Because it starts from 1. I could just count up to here. So I guess in this case, we iterate through 1, so that means we've seen it. And then we check 1 again. We've already seen it. It's already been set to 0. So that means the only missing number here is 2. So that'll be added to our 2. Yes. Okay, so this is our storage array, the results. And we just want to iterate over the numbers here. So I guess the result storage array should just be 1 times the length of numbers. I'm just thinking right now if I want to do this based on ones or not. I said technically it doesn't really matter.
So just do... Well, why not just booleans then if it's going to be binary value.
Yeah, that's probably a better idea. Yeah. Okay, then we'll just do a boolean and then the results. So we're just checking here if it's been seen already. If it hasn't been seen, then we just want to add that to our resulting array. And this is where we want to have the logic to mark it as seen or not. So
Okay, so we have an array of false. So array n is equal to true. And
yeah.
then, okay, just walk me through. Okay, can you give me a dry run on this code?
Yeah. So I'll also try running in my head. So I'll just try run the first example again. So we'll just have a bunch of falses. And based on like the first number, so for example, it's 4. That means that in this in our storage array here, we'll update the fourth element to be true.
Okay.
For example, and then we kind of repeat this process as well for the next couple numbers. So if this is 3, this is 2, then we'd also mark this as true here to say like, okay, we've seen 3 before. And then likewise, we mark 2 as well, saying that, okay, we've seen 2 before as well. And we're just going to start at 1 here. So this will repeat for like all the other numbers as well. So up to, I guess like the last number. And we're starting at 1 here because we don't want to kind of count the 0 that we have stored at the start. Because our storage solution is basically still using a 0 indexed array, but the question only wants us to kind of get the range in 1 to n.
Okay. Okay, can you run out some test cases, make sure it's working?
Like dry run again, or just
like write some test cases, like print it out or assert it or something.
Oh, okay. Yes. Guessing we're allowing duplicates here. So we'll just have a bunch of 1s as well. Oh, okay. Nice.
Okay, cool. So what's your time and space complexity?
Space and time complexity is both all n, since we use like a storage solution that kind of matches the size of our input array. And time complexity is all of n as well, because we're kind of iterating through every single number. It's technically like all of 2n, but we're simplifying it to all of n.
Okay. So O of n space, O of n time. Can we optimize on space?
Optimize on space.
This is a follow up.
Yeah. Maybe we can use the same array to kind of like mark it if we've seen it or not. So I actually kind of picked up this idea recently from a different question where rather than using our storage array here with booleans to mark the number as seen or not based on the current index, we use the original array and we kind of update the number in that position to be negative. So I guess like an ideal example, I'm just gonna erase this. And I'll just copy this. is, for example, like let's say we want to do the same approach. We want to iterate through our input, and the first number is 4. So in the input array that we've been given, I want to go up to the index of 4. So 0, 1, 2, 3, and 4. And at the number 8, which is at index 4, I want to update this to be -8.
Sure.
And this works because we're only doing it from 1 to n. So we don't have to worry about any pre-existing negative values.
Yep.
And by setting as negative, it works the same way as like setting it to true or false.
Yep.
So we can iterate through at the end again, not to check for booleans, but rather to check for negative values and like append it the same way we have in our res array.
Okay. Let's see. Try it out.
So I'll just do something. I guess we want, since we're editing in place, and this is where we want to kind of mark the numbers as negative to be seen. The original array. So nums that I equal to So I'm basically having this condition here to say that if the number's been marked before, we don't need to mark it again. Otherwise, we end up like kind of flipping our values too much.
Mm-hmm.
And I'll do the same thing here where kind of iterate the nums. And we just append the ones that are of greater than 0, which means that they're not negative, so we haven't seen them.
Yeah.
And one. I guess I'll do this.
Give it a run.
Yeah, I just need to double check this logic here since this doesn't. That's something with this condition. Oh, wait, I'm actually kind of trolling. Right. So I'm not actually like, okay, so there was a problem here where I'm not actually marking the number that I'm seeing to the actual index.
Yeah.
So I need to kind of sort that out. So for example, I've seen, so number 4, just added I need to update this position somehow. So I guess it'd be, this is same condition here where I don't want to double mark it or else I'll end up flipping values, but I guess this will be nums I, and then
Mm-hmm.
so if it's been marked before, then we don't want to mark it again.
Yeah.
And then I guess the same logic here. Four, yep. And then this is checking.
Looks off.
Yeah, definitely not it. It's definitely I'm checking in here then. So basically saying
Can you dry run it?
yeah.
Like just like do a small example of 1-1.
Oh, okay. Yeah. Yes.
And like walk me through it line by line. So res starts with empty, and then okay, what are we doing here?
Empty. Then we want to iterate through every single numbers in our array, starting from our first number here. And basically we're saying that at this point we've seen 1. So we want to update in this array at index 1 to be negative. So at nums and then 1, update this to be negative.
So updating this one to be what? Negative?
Yeah, because we're doing it by index.
Okay.
And then there's another, the next one, we kind of have a check here. Okay, have we seen this number before? In this case, we have, so we don't want to update it twice.
Okay.
Yeah, because then that'll confuse it and basically think that we haven't seen the number, even though we have.
Okay. Let's run in this. Let's see. So 1 1. What should that output to? Right.
Yeah, but it's definitely the condition I have here where,
Well, it's putting 1.
yeah, it should be outputting 2. So it's
Yep.
definitely the condition I have here where I'm not marking this correctly,
Well, what is this marking right here?
which is
Why is 1 positive here?
hmm. It's basically saying that. Actually, yeah, wait. Actually, I'm actually getting confusing myself. So this should be saying, oh, because we're going based on ones, which means that this should be negative. If we're doing, oh right, because sorry, like let me like re-explain that. So earlier the solution was to have a storage array, which is of size n+1.
Yep.
And that allowed us to kind of keep our 0.
Mm-hmm.
And earlier you kind of noticed that there was a 1 here,
Yep.
saying that we skipped that 0.
Mm-hmm.
But in this case, because we're using the same input array as we're given, that means that we also have to include the starting number. So we have to include index 0. And that's the piece of logic that I'm missing here, where rather than just marking this as 0 and 1, it should actually just be marking this as a 1-based index, or a 1-based like index array.
Yep.
So I guess because of that, I think I should just be subtracting this. And then checking.
Yeah.
Yeah, there we go.
Yep. It's just like an off by 1.
Yeah.
Yep. Messing up the indexing a little bit, but let's see. Should run now. Wait, 2 and 5.
2 and 5. That's not right. So that's been updated earlier to.
Oh no, did you change it? Oh wait, let's see.
Oh, I changed the 1 here. My bad. I was like showing it as an example. Should be it? Oh no, no, that shouldn't be it. Yeah.
Wait, 5 is missing. 2 is not missing.
Yeah, 2 is not missing for sure. It's 5 and 6 that are missing from this.
Yep. Okay.
I'm guessing it's bad practice to print out the actual array itself. So, Okay, we're treating this as a 1-based index array by subtracting 1.
Okay, I see. Wait, if
then
I is
based on this.
So right here, we're adding all the values greater than 0 to the result, or?
Yeah, so any value that has been marked as -1 means that we haven't seen it before.
Okay.
So we want to kind of add that value, but
yeah. So how would you debug this? I mean, like, try printing it to the nums and just see.
Okay, there we go. That's what I was saying. We've seen 1. For some odd reason, we haven't seen 2. Why is that the case?
Try adding some print statements here.
Yeah, probably. Yeah. Rather too many. Okay.
Yeah, it's something wrong with the way you're marking it.
Yeah, it's like I'm getting tripped up by the indexes.
Yeah.
So kind of printing the.
So what is this one? It says so for the first one it says
Okay.
7.
Oh, I guess this should technically be this, and then just printing I itself, because we want to look at the indexes
Yeah.
rather than the number itself. Or if I can. Yeah, so I guess our first iteration 4, we definitely want to jump to 7. Yeah, so that should be right. Yeah. We should be
Wait,
jumping
so
to 7 in this case.
let's just do this. Let's just break. Let's just simplify this. So after the first run, what should be marked?
So 7 should be marked as negative. Yeah.
Okay. What about let's run it for a few more times, like 5.
I think, yeah, that's not gonna
Oh
go
shit,
up to
sorry.
5 like
Oh
this.
yeah, sorry. Yeah.
I'll run it. Oh, okay. So we go up to 2 here. But yeah, 2 is
Okay.
not being
The
marked.
the
Yeah.
the problem is like you're modifying the array. So when you're trying to like index it later, it could be it's like a -7. Like you're modifying elements of the array. Pretend for the first one, right? For the first iteration, like for the first iteration, you marked 7 here.
Yeah.
So I think when you get to index 3, you go -7 minus 1. That's -8 or something. So I think you usually take the absolute value of when you try to when you try to index here.
That's the value when I try to index.
Like it's working up until you get to -7 here.
Yeah.
Like you see, for example, after the first run, this is what happens. And then you have a pointer, right? And then when the pointer gets to -7 here, or -4, -3, what's -3? It's right here, right? -2. But like, okay, what happens here? It's -2 instead of 2. Does that make sense?
-2 instead of 2. And this will be for 3.
Like
So
what
that's
like you have this loop right here, like right? So you're at length of nums, and this is pretend I is at index 2. I is at index 2 right here. So
yeah.
it's looking at this value -2. So what would happen here? Nums
Uh,
I, you see what I mean?
yeah. Yeah. So then, yeah, I would have to get the absolute value of this for both cases. Looking at.
Okay, yeah, just clean it up a little bit.
Yeah. I'll just run it. Okay, there we go.
Nice. Cool. Let's go into the or like write a couple more test cases. I'll get the next question going.
Okay. Seems to be good.
Two, three, four. All right, cool. let's move on to the next question. Can delete that, or I'll just throw that to the bottom. So this is the next question. We're gonna be given a grid, and I'll drop the examples here. So we're given a grid of zeros, ones, and twos. 0 just means it's an empty cell. 1 is it's a fresh orange, and 2 it's a rotten orange. Essentially, what we need to do is we need to figure out how long it takes until all the oranges are rotten, right? And the only way for something, for basically the only way for a orange to go from fresh to rotten is if it's next to a orange that's already rotten.
Yeah.
Yeah, you can like walk through the examples and then clarify there. But
so 2 is 0 is empty, so you can just ignore this. Oh, okay. So I guess this is like if it's all rotted from the start, or there's just no oranges in general, we'd return -1. But the usual scenario is that we have a rotten orange or a couple rotten oranges. So I guess this could be 2 for like another rotten orange, for example.
Yeah.
And we have kind of like a time lapse to see how long this would take to spread.
Yep. We gotta spread the rotting.
Yeah, the rotten. Okay.
So why is this one 4? Can you simulate it? Or let me know.
Yeah, I'll simulate. So I guess based on that, since it's 4 directional, by time lapse 2, or should be this. So updates the right and the bottom oranges.
Mm-hmm.
Then based on that, it should also update the next couple of like 4 directionally neighboring oranges.
Mm-hmm.
So update this.
Yeah.
And then update this.
Yeah.
So among takes time lapse like 4.
Yeah.
Yeah.
Exactly, you're correct.
Okay. Okay, so I guess like just I don't think that that depth first search is the way to do it, since if there's a case of like multiple rotting oranges, I don't want to just explore one and then leave the other one for later. I kind of want to explore them simultaneously from the start.
Mm-hmm.
So for example, if I just went with like DFS and there were like 2 rotting oranges, I'd only be exploring the first one, and that wouldn't give me a proper time lapse of what would happen along with the second one. So if there's multiple rotting oranges at the start or at like a certain stage, I would imagine that I would have to use breadth first search to kind of just go at them simultaneously and level by level, since it only spreads to its neighboring at once, but not kind of in a straight chain of any sort.
Mm-hmm.
So yeah, based on this dry run, for example, if I were to use breadth first search, then I'd have a queue at the start to kind of say, okay, our first rotting orange is based on like 0 and 0.
Mm-hmm.
In the case that we had multiple, like this will be another one and this will be another one. then I also want to consider those rotting oranges at the same time. So that this will be like 0 and 2. And then this would also be, I guess, like, what, 2 and 2.
Hmm.
And so for each one, for example, I just want to get their like neighboring oranges. So maybe I'll have something to kind of check all four directions. So for example, like an array, like -1, to say that from the current position, I want to check the left side. The same for the right side, and then top and down as well. So this is 1, this is -1. So for example, if I'm at like our first orange here, I'm going to kind of iterate through my directions here
Hmm.
and kind of add these values to whatever rotting orange I'm currently looking at. So for example, like for 0 and 0, I'd be checking 0 and -1, and then basically the same as this direction. Or if I'm looking at 2, I kind of want to look at like 2 and 1. 2 and if anything's out of bounds, I also have to handle it if it's out of bounds. So if I'm handling a running orange in the corner, that means I can only check the left and top oranges. So I definitely want to have like an out of bounds check. So if it's 2 and 3 here, then I don't need to check that. Likewise, if it's like 3 and 2 here, I don't need to check that either. But if it's 1 and 2, which is the orange above it, then I do want to check. So only these two cells are like, or these two like, yeah, these two cells are what I should be checking when I do my breadth first search. If that makes any sense. Am I explaining clearly?
Yeah, yeah, that makes sense. So let's just say it. Could you just walk it through at a high level of what the steps of the algorithm are going to be, starting with the input? Like you said a few
Yeah,
things, but just want to make sure. Like let's just say the algo here at the very
yeah.
bottom.
Okay, so the algo is basically we want to iterate our input at the start to kind of get all of our rotting oranges at once.
Okay.
So iterate through all cells and get all the rotting oranges into a queue. And afterwards, we want to implement our breadth first search algorithm to kind of go through our queue. So implement breadth first search to iterate through our queue. And then based on that, we kind of for every iteration we have in our breadth first search algorithm, when we go through a running orange, we kind of want to check all four directions. So check all four directions, current like running orange,
Yep.
and also check if I don't consider oranges at all times.
Yep. Okay. So one thing would be, how do we know when? How do we count how long it takes for all of everything to be run?
So I guess as we kind of go through, um, every time we kind of empty out our queue, for example, or we kind of finish our queue for that level, we want to say like, hey, we've already updated this time lapse and kind of like add +1 to our result.
Okay. Cool. All right. I think it. You're going the right direction. Go ahead and implement it.
Oh, sorry, I think you cut
Oh, I
out
cut
there.
out. Oh, one
Yeah,
second.
I think you're cutting
One
out a
second.
few times.
Wait. How's it now? How's it now? One sec.
Still a little bit like on and off.
Yeah, my audio is dropping frames. One sec.
No worries. If anything, like I can probably
Wait.
read off the screen, or we can
One
just
sec.
take a break for a bit.
Wait. One sec. Can you hear me? I can hear you perfect though. It's weird.
I don't know why in Google Meets at least like your They're kind of like static-ish at moments.
Yo, chat, can you hear me? Sir. Sir. Wait 1 sec. Wait. I'm gonna pause this. Okay, what I was saying is like, go ahead and just implement that code.
Oh, okay. Yeah. Guess I'll just call this grid. Zero. So this is where we want to get all of our currently oranges.
Yeah, I'm moving to Google Fiber ASAP. This is ridiculous.
I guess from collections import to oops. And then what is it? It's 2 if it's a rotting orange. Okay, so Q and
Chat, everything is good now, right? You can hear me too, right? When you're...
yeah, sounds perfect.
Perfect.
Yeah. So this should get all our rotting oranges, and then this is basically saying I have not practiced breadth first search in a long time.
Gotta get used to it.
Okay, going by level. Don't want to process any new values. It means I want to keep our popping in the same length of our current queue. So we want to get only our current queue, and then we kind of want to go through our queue. So I guess. So I guess same as earlier, where if we have a queue of 0 and 0, it'll only pop our 0 and 0 here. And I want to add my directions as I had earlier. Just makes it a little easier to see. Okay, now so for our current rotting orange, we want to check all of its directions. So for x, y, in directions, we want to see if this is a. I guess this will be a little better. So if this is currently an orange, we're going to rot that orange. If there's nothing there, then we just kind of ignore it. So that's keeping it in the station. So dot the current neighboring orange. And we repeat that for all of our oranges in our cell. And kind of at time. Is time always at 0? It should be. Wait, does our time start at 0? Yeah, I'll just have it at 0 for now. I'm pretty sure it starts at 0. So every time we update our oranges, we also want to update our time.
Mm-hmm.
So okay. I need to go through like my breadth first search implementation since I don't remember doing breadth first search.
Yeah, no problem.
Okay, so yeah, for so go through the oranges at the current time.
Can you index out of range?
Oh right, yeah. I have to check if they're in range. So if r is greater than 0, guess I'll just compress this to make it also a little easier to read. Check out of bounds. So check out of bounds, and then if the current neighboring orange is there, we can override that by adding it into our queue. And the scaling elements from the solution. I don't think I am. Oh, sorry. Plus X. That should do it.
Creating a loop, infinite loop.
Yeah.
What's happening?
Strange. Oh, if we visited before, we don't want to revisit our rotting orange because we're checking all 4 directions.
Mm-hmm.
So I guess we'll have a visited set.
Like,
and then
is there a way we could do that without creating a set?
Without creating a set?
It's the same thing, but like.
Yeah. Oh, okay. Maybe like the same as earlier, where we kind of mark it as negative.
Mm-hmm.
Yeah. So I guess
Or just mark it as a 2 or it's rotten now, right?
Mark it as a 2?
Because 2 means it's rotten.
Right? Oh, right. Yeah.
Getting 5.
That's not right. Log is 5.
What's a quick, easy way to debug this? Like, how do you debug it?
I guess I can print my current queue and time to kind of see the status of my oranges.
Or you print the grid?
Or I print the grid.
You get messy.
Yep, so that makes sense. This isn't updating though. Yeah, why was that updating? Check left, check right, upwards and downwards. This is not being added in.
Right. Wait, this is row and column?
Yeah.
So this actually checks up.
Oh. Check up, check down, check right, check left.
Yep, that looks good. Where else could be wrong?
We are checking for ones here, so that should be fine. We're doing it by adding our directions. Let's see. We're marking the ones we've seen. Yeah, when you append this should have also been added. So why is this not? Oh, I also have to add these, I think, because we're not looking at the current cell, we're looking at the directional ones. So then run this. Still 5, but okay, we are visiting them properly now. how's this continuing if our queue is empty?
So it starts at 0. Maybe just print out here the time.
Oh, that's okay. Just make any difference.
So
Probably
after
not.
1 iteration is this. After 2 iterations, after 3, after 4, it runs one more time. What is it doing?
I'm also gonna print the queue if that's okay.
Yeah.
Queue in time. Wait, what?
Oh, I see.
Oh. Just checking this last 2 and 2.
The off by 1 issue again.
I'm not sure if subtracting 1 from the time would actually be the proper way of doing this.
Okay, so what's happening here on the first one? After 1 iteration is 1. After the second iteration is 2. The third. After the fourth, it's, but Q is a 2. Q is a 2, right?
Yeah.
That makes sense why it's running one more time, because pretend we have 2 and 2.
Yeah.
If there's nothing rotting after that, like 2 will run. But at that point, everything's already rotten on that last iteration.
Yeah, maybe we want to have a condition here where we check once we have gone through all of it. Or, yeah, in this like condition here, if Rn is greater than 0, time plus equals 1, to say that we have rotting oranges and we already went through them.
Well,
otherwise, if
this is still gonna work, right? Or this is still gonna increment it. Let's run 5 here. Because, for example, do you see the very last run? It says 2. The DQ is 2 and 2. Right. That's the very last element. Because we still need to check the last element, even though we flipped it to a 2. Everything's 2 at that point. But we don't know if everything's... What if there's like another thing in the right corner? One more to the very right of that one. In that case, it's not, but... I mean, if we know that that's the case, we could always just start this by -1. That would work, but...
Or just, or subtracting it.
Yeah, you're just subtracting 1.
Yeah, I wasn't sure if that was like the right way of doing it. I'm trying to think of edge cases that might be against that.
There are cases where your algorithm still won't work.
Yeah, like if there's like a...
What if we have a bunch of... What if we have a grid like this, right? And then we have 0 and we have 1 here. So what happens here? What should be the result here?
Shouldn't this also be 4?
Well, how is this one ever gonna rot?
It has nothing to spread to.
So after your algorithm runs, it's gonna do this. It's gonna return 4, right? Yeah. But it should actually return -1.
Oh.
So it's impossible for that fresh orange to ever rot.
I see. Yeah.
So it's like, how would you catch that case?
I mean, I guess one way of doing it, which is to just iterate over the array again to check if we have any oranges left.
Yep. That's one way.
And then maybe the other way of doing it would just be maybe we could just like kind of flip the approach instead of going for rotting oranges at the start. We go for fresh ones and we basically see if it's like next to a rotting orange. And if it is, then we don't keep that in our next like time lapse.
I think your other way works where we just do one more loop, or we could just count up how many rotting oranges are when you do the loop, your very first loop, and subtract from that, or how many fresh oranges.
Yeah.
So if you had a fresh oranges count, like start at 0, and then here, if it's fresh, you increment it,
Yeah.
and then whenever you convert something from a rotting to a fresh, you decrement it, and that finally, if the fresh is greater than or equal to 0, then you return time. Otherwise, you return -1.
Yeah.
But yeah, that's one other way. Um, yeah, but overall, you solved the question, most of it. Just that one edge case. How do you think you did?
Oh yeah, I definitely need a lot of improvement, especially with how I'm explaining it. I'm like kind of lagging behind how I can like consistently explain it.
Mm-hmm.
So, because yeah, I guess like the idea of the interview is normally also to have you on board with what I'm thinking. But I
Mm-hmm.
feel like most of like or how I'm explaining it is only meant for like me to understand. So I'm not exactly explaining in a way that both of us would understand at the same time. I
Mm-hmm.
also just need to improve on like the way I dry run things or like the way I debug it.
Mm-hmm.
So definitely like the next case kind of caught me off guard. I wasn't properly debugging it as I should.
Yeah.
So I think like yeah, I got too much help there,
Mm-hmm.
as well as like this case where I wasn't sure about like just setting time to -1 or just returning time to -1. In that
Yeah.
case, though, I'm not really sure what to do there, apart from like maybe just practice and intuition of it.
Yeah. Well, I think the solution is just -1ing off of it.
Oh,
Because you know in the last iteration that the last iteration is always you don't want to count it usually.
yeah.
So
Should
the
be like the last rotting cell, but I
yeah,
wasn't too sure on that. Yeah.
but yeah, I think honestly the way you explained it was good. I don't have any issues with the way you explained it. I understand
Like,
both your approaches. So I'll walk you through what I thought of first. The question. The first question, you talk everything was good. You talked through the solution well. You talked about the solution before implementing it. You did dry run the code, but your dry run could be better. For example, when you did your dry run, you weren't even referencing the actual code. You were just like you were just simulating it in the comments. But you need to prove to me that your code works. So you need to step line by line and then update the comments based on how the code is running, right? Because you can go in the comments and just say that it's working and just like simulate it in the comments, but your code was doing something else.
yeah.
So I would just so the way I do it is I go line by line and then I update my comments as I go line by line, right? Or
Oh, okay.
I simulate the variables while I go line by line, kind of thing. But I think overall you're good at coding. You know how to code. It's just you just with the off by ones, you were just messing up. So yeah, you're messing off with the off by ones, and the only way to solve those off by ones is like when you're practicing, don't just try to like finesse it or tinker with it until it works. Actually, try dry running it and figuring out why it's breaking. Right.
Yeah, definitely dry run to debug
Yeah,
rather than just debugging by tinkering.
yeah, because like I used to do it like that too. I would just it wouldn't work, so I'll be tinkering with it, and then finally it would work. But in an interview, that's like the worst way to do it in an interview. In an
Yeah.
interview, if somebody saw an issue and then they dry run it, and then they caught the issue, that would be plus points for me. Versus if they just tinkered in it and then suddenly it's working, like oh nice. I mean, I've seen
Yeah,
that.
because
You
it,
know what I mean?
yeah. It looks like you're guessing pretty much like what I did.
You want to be methodical with it because
Mm,
you even saw that you weren't being methodical with it. That's why it took you longer to find it. But then when I was like, when you watch this over, when I was like, okay, run it line by line, and then print out some of the stuff, right? And then you found it way faster.
yeah.
Like
Okay.
once you actually were dry ran it better, you figured it out. I think with the way you debug too, you didn't think to just do print statements and stuff. I think with the just working on when to write the right print statements to
Okay.
debug it. But overall, I think the way you coded it was good.
Yeah.
There was
That's
just a small issue with it,
yeah.
but 95% of the code worked, but it would just break on edge cases. So I think you're pretty close. It would just be ironing out that last little bit of making sure you can dry run the code and making sure you could write code that's bug free.
Yeah. That makes sense. Yeah. Thank you.
But your process was good. I think the way you ran the interview was perfect. You just need to, yeah, be able to
Drive.
dry run the code better. So just I wouldn't change too much on how you explained it. I understood everything you were kind of saying there.
Okay. Yeah. Thank you.
Yeah,
Thank you.
my notes were
Yes.
pretty much just needs work on debugging.
Yeah.
The debugging skills could improve. That was pretty much my notes.
Thank you. Thank you.
Cool.
Um. Appreciate it. Yeah.
Yeah.
Actually, the only thing I have a question is like when to kind of do this stuff because I heard that like if you use print statements during like an actual interview, that's like minus points.
Yeah, it depends on the company you're interviewing for. So, for some companies, when they tell you prioritize working code, most startups and stuff, doesn't matter if you print. That's most engineers actually print. I even use print statements to this day too. I use the debugger for sure, but if I'm in a coding interview, you don't want to use a debugger. Just throw proper print statements. In companies maybe like Google, like and Meta, or ones that don't let you run it, then you actually have to dry run the code. So it all depends on the interview you're doing. And but those companies, they don't prioritize working code the same.
Oh, okay.
So
I
I
didn't know
would
that.
say it depends on if they say that if they allow you to run the code, just do print statements, honestly. But you should ask. I wouldn't just. That's the way I
Yeah.
run them. Like most of the time when I was running interviews back in the startups, I would just say just feel free to run the code and write print statements. I want you by the end of this interview to have code working because I'm only gonna pass you if you have working code.
Oh, okay.
Mostly. So it all depends on the company, but either way, like when you run into a bug when you're lead coding, you're not using print statements. Or
I do. I just
okay,
don't know if it's like for interview settings. That was the only thing that stopped me really.
oh, okay, I see. I mean, yeah, it's a good point, but since we're prioritizing working code,
Yeah.
yeah. But
Got
cool.
it.
All right, thanks for taking the time out. That was a good job.
Yeah. No. Appreciate it. Thank you as well.
Yeah,
Yeah. It
let me know
was
if you
really
want to do
helpful.
another one again soon, cause yeah, I want to get you right for your new grad when
Yeah.
you're graduating.
I appreciate it. Yeah.
All
Thank you very much. Yeah.
right, catch you, man.
All right.
Peace.
Later. Peace.
Yeah, they don't let you run the code. How do you know you didn't mess up? Well, you dry run the code and you prove to them that the code that you write is working.